We have an AP versus a GP over here. And for the information that is given, I'm going to try to consolidate it in a little table that I'm going to build for myself here, where I can see at a glance AP versus the GP. So according to the question, the 9th term of the AP, the 10th term of the AP, and the 13th term of the AP, they are the first 3 terms of the GP. So 1, 2, 3, first term, second term, and the third term. For the AP, the first term is A, and the common difference is D, which means that for the 9th term of the AP, expressed in terms of A and D will be A plus 9 minus 1, which is 8 times D. The 10th term will be A plus 10 minus 1, 9 times D. Then A plus 13 minus 1, which is 12 times D. And these are actually consecutive terms of the GP. So for this GP, the common ratio can be obtained by taking the third term divided by the second term. The third term is A plus 12D, and the second term is A plus 9D. So this is the common ratio. There's another way for us to determine the common ratio, which is to take the second term divided by the first term. And the second term is the 10th term of the AP. So it's going to be A plus 9D divided by A plus 8D. And they are both the common ratio of the same GP. So these are equal. And now we have an equation in terms of A and D. Let's make use of this equation and let's see whether we can show a relationship between A and D according to what the question asked for. So I'm going to cross multiply this. So I have A plus 9D times A plus 9D, A plus 9D square. This is equal to A plus 12D multiplied by A plus 8D. Expanding this, we have A square plus 18AD plus 81D square. And expanding this, we have an A square plus 20AD plus 96D square. A square can be cancelled, and if I were to bring the rest of the terms over to the right hand side, 20AD minus 18AD, that gives me a 2AD. 96D square minus 81D square gives me a 15D square, and this is equal to 0. Factorizing out D, we have this, then 2A plus 15D. This is equal to 0, which means that D is equal to 0, but according to the question, D is a non-zero term, so this is not applicable because D cannot be equal to 0. Or we will have a 2A plus 15D is equal to 0. So A is equal to minus 15 over 2D, and this is what we are supposed to show. We are supposed to find the sum of the first 16 terms of the arithmetic sequence, and the notation is as 16. And this is equal to 16 over 2, the number of terms over 2, 2A plus n minus 1, which is 16 minus 1. So 16 minus 1 times D. And what is A? According to part 1, A is minus 15 over 2D. So we have 16 divided by 2, 8. Then 2 times of A, which is minus 15 over 2D, plus this is 15D. So we have 8. And this is minus 15D plus 15D. So what is going to be the sum of the first 16 terms? 0. In order for us to do part 3, we need 2 pieces of information for the GP, which is the first term and the common ratio. The first term of the GP is A plus 8D. So this, which is A plus 8D, is going to be equal to A. I'm going to replace it by the expression in terms of D, which is minus 15 over 2D plus 8D. So for the first term of the GP, it is equal to half D. As for the common ratio, we have determined previously that common ratio is the third term divided by the second term, or the second term divided by the first term. I'm going to use this, the second term divided by the first term. So the common ratio is going to be A plus 9D divided by A plus 8D. And A is minus 15 over 2D plus 9D divided by minus 15 over 2D plus 8D. And all the D's can be cancelled because D exists in the numerator and the denominator, and this will leave us with a common ratio of 3. So according to the question, the kth term of the arithmetic sequence, and that is A plus K minus 1 times D, is equal to the fourth term of this GP. So the fourth term of the GP will be the first term of the GP, which is half D, then the common ratio to the power of 4 minus 1. So this is the fourth term of the geometric sequence. So A here, I'm going to replace it again so that I can have an equation that is in terms of K and D. So this A, if I were to replace by the expression in terms of D, this is minus 15 over 2D plus we have a K minus 1D is equal to 3 to the power 3 is 27. So we have a 27 over 2D. All the D's can be cancelled again since it's non-zero. So we have a 15 over 2 plus K minus 1. This is equal to 27 over 2. And this will help us to work out the value of K. And that is equal to 22.